Hello everyone. In this video, we're going to be looking at more missing angles and I'll be introducing Pythagoras' theorem. Let's start by looking at more missing angles. This one is sort of a formula that you can use. Say we have an acute angled triangle with a line coming out like this, and we had these angles. And I'm going to label them. This would be D, this would be C, and these two would either be A or B. Now, this formula is A plus B equals D. Now, the reason this works is because there's 180 degrees in a triangle and 180 degrees on this straight angle. So, let's say this angle was 65 degrees and this angle was 45 degrees. 65 plus 45 equals 110 degrees. To prove it, we know A and B is 110 degrees, and then to figure out C, we'll do 180 degrees minus 110 degrees, and that equals 70 degrees. And to check that D is 110 degrees, we know that this angle is 180 degrees, and 180 minus 70 is 110. Let's look at another tricky missing angle problem. Let's say I had a straight line with two triangles on it. And let's say we start with the angles 135 degrees, 60 degrees in this triangle, and 45 degrees in this triangle. And we're given a right angle here. So, let's figure out the other angles. We know that the square represents 90 degrees, but we can't write 90 degrees because it's made up of two angles. This one here and this one here. So we can't do that one just yet. However, we know that this is 180 degrees, and 180 minus 135 is 45 degrees. Now that we have two angles in this triangle, we can figure out the last one. 60 plus 45 is 105 degrees, and 180 minus 105 equals 75 degrees here. Now, we know that these two angles combined is 90 degrees, so 90 degrees minus 75 degrees is 15 degrees. And then there's two ways that we can figure out this last one. We can do the 180 minus 60, or we can add these two and take that away from 180, but I'm just going to use the simpler method. 180 minus 60 is 120 degrees here. And to double check that these triangles are correct, 15 plus 120 plus 45 does equal 180, and for this triangle, 75 plus 60 plus 45 also equals 180. Now, let's look at Pythagoras' theorem. This theory involves right-angled triangles and their side lengths. The theory states that a squared plus b squared equals c squared. An easy way to understand this is by drawing a right-angled triangle like this with the dimensions 3, 4, and 5. Now, with these grids drawn, you can see how the 3 meter side has a 3 by 3 grid, the 4 meter side has a 4 by 4 grid, and the 5 meter side has a 5 by 5 grid. So, let's add a squared and b squared and see how it equals c squared. We'll square 3 meters, which equals 9, and we'll square 4 meters, which is 16. 9 plus 16 equals 25. Now that we have 25, we have to do the opposite of squaring and square root 25. And that equals 5, because 5 times 5 equals 25, which then means that the hypotenuse is 5 meters. This 3, 4, 5 triangle is really popular for marking out a perfect right angle or checking if something is a right angle. Builders will mark out a big right-angled triangle with the dimensions 3 meters, 4 meters, and 5 meters, which gives them a very accurate 90-degree measurement to make sure whatever they're building has 90-degree alignments. I hope you enjoyed this video. Let me know what you think in the comments. In the next video, we're going to be looking at more Pythagoras.